Stretch your arms out. If you map the 4.5 billion year history of Earth across your body, your right arm is a hellscape of molten lava, and your entire torso is just billions of years of microscopic slime. Animals don't even show up until your left wrist, and all of human history fits right here, on a microscopic sliver at the very tip of your left middle fingernail. It is easy to look at that timeline and assume the long stretch before we arrived was a quiet incubation period, a peaceful cradle slowly preparing the planet for us. The reality is early Earth was a hostile, churning hellscape. It spent 99% of its existence actively trying to destroy everything on its surface. Every feature of our lush, habitable world was forged through a sequence of devastating planetary-scale disasters. Go back 4.5 billion years, and our future home is nothing but a sterile, glowing ball of magma. Then, a Mars-sized planet named Theia plowed directly into it, knocking Earth off its axis and blasting a moon-sized ball of magma into orbit, creating the moon and setting up the gravitational rhythms that drive our oceans. As the crust slowly cooled, an unrelenting barrage of asteroids and comets pummeled the surface. These impacts acted as a cosmic delivery system, depositing the massive amounts of water necessary to form the very first oceans. Down below, intense internal heat combined with this cosmic bombardment forced mineral-rich water deep through cracks in the crust. This extreme pressure naturally injected heavy space metals, like gold, into the rock near the surface. Fast forward, and supervolcanoes regularly exploded billions of tons of lava and ash across places like Nevada. When features like the Atlanta caldera collapsed, they shattered the ground, creating a perfect network of pathways for gold-rich fluids to rise. Today, geological treasure hunters like Nevada King target these zones of ancient catastrophic violence. By mapping an entire 7-kilometer-wide collapsed volcano, they have located massive, concentrated deposits of oxide gold, the physical building blocks of our biosphere and the bedrock of our modern economy, required our planet to be repeatedly smashed and ruptured. About 4 billion years ago, deep underwater near hydrothermal vents, chemical reactions began turning simple elements into complex biomolecules, capable of making more of themselves. By 2.7 billion years ago, microbes called cyanobacteria had taken over the oceans. They developed a biological tool called photosynthesis, converting carbon dioxide into energy. As a byproduct, they pumped enormous amounts of oxygen into the atmosphere. To the anaerobic microbes that thrived on methane at the time, this new oxygen was a deadly poison. This atmospheric shift wiped out almost all early life on Earth in an event known as the Great Oxidation Event, the first mass extinction. Because the oxygen replaced the methane, it also destroyed the greenhouse gas blanket that kept the planet warm. Earth was quickly plunged into a global ice age, locked in a deep freeze for hundreds of millions of years. Life's most important evolutionary leap suffocated its competitors and nearly froze the entire planet, proving that biological progress is often a deadly trial by error. Eventually, the ice melted, and complex life evolved, and almost every piece of dry land mashed together into one giant supercontinent called Pangaea, surrounded by a single vast ocean. Then, 252 million years ago, a massive volcanic complex known as the Siberian Traps erupted continuously for 1 million years, pumping massive amounts of carbon dioxide into the air. The oceans turned acidic. 96% of all marine species and 70% of land animals vanished entirely. With the apex predators completely cleared out, a massive biological vacuum opened up. This allowed dinosaurs to eventually evolve, multiply, and dominate the fractured tropical continents that followed. That reign lasted until about 66 million years ago, when a 10-kilometer-wide asteroid targeted the Yucatan Peninsula. In a blinding flash, 160 million years of reptilian rule ended. A nuclear winter set in, wiping out 75% of all species on Earth. The planet continuously cleared its ecological board, violently removing the ruling classes so new biological dynasties could take their place. In the smoking aftermath of the asteroid impact, no land animal larger than 25 kilograms survived the cold and starvation. But hiding in the rubble were small, shrew-like mammals, our earliest ancestors, who managed to scavenge enough to stay alive. If that asteroid had missed Earth, the dinosaurs would have maintained their ecological dominance, and mammals would have remained bottom feeders. Instead, they filled the empty niches, rapidly evolving over millions of years into the first hominids that could finally stand up and walk upright. When you pull all the way back out to the tip of your left fingernail, the true context of our existence comes into focus. Human civilization emerged as the lucky byproduct of a 4.5 billion-year cosmic lottery. Earth is a brutal geologic forge, and every breath we take today was paid for by a planetary catastrophe.